whatever you are seeing here, these are the subnets that we are creating, okay, under the hub architecture. Okay, so this is my virtual network. This is my virtual network. Which virtual network it is? It is the it is the hub virtual network. Okay. This is the what is this called as? This is called as the hub virtual network. So what is that hub? That hub is, so here it is Azure B1 hyphen hub hyphen VNet. The CIDR is 10.1.0.0/16. Okay, this is the hub network. Okay, and then this is created inside the hub resource group. Whatever you are seeing, this is created under the hub resource group. So this is my Azure B1 hyphen hub, Azure B1 hyphen hub. Okay, which is created in East US. Okay, which is created inside the East US. So inside this, are we creating anything means? So here we are creating a jump server. So inside the subnet, we are going to create a jump server with the IP address 10.1.1.4. So this is the IP address of the jump server. Okay. So this is the hub architecture. So to create the hub architecture, what I am going to do here is, let me go to the E drive somewhere. So these are the commands which we are going to execute in the shell, Azure shell. Okay. So if you see AZB1 hub, so that is the resource group. So if you see here, AZB1 hub is the resource group, which is created in East US, and then AZB1 hub hyphen VNet and 10.1.0.0/16. So now what I will do here is I will go to shell.azure.com. Shell.azure.com. Firewall subnet, Bastion subnet, gateway subnet, and EP hyphen subnet, EP or else endpoint subnet. Okay, so let me copy this. So first of all, AZ account show. As you go is there, AZ account set hyphen hyphen subscription, set hyphen hyphen subscription is dev. Now if you see AWS accounts, okay, now it is in the dev subscription. I'll paste here. Once I have pasted this, what we are pasting, the resource group, and these configurations will be created. Okay. So once it is done, then what we are going to do here. I'm going to create the network security group with the help of these commands. I'll go to Microsoft Azure. Let me go to the resource groups. So Azure B1 Hub is created, and then I can go to virtual networks. Here you can see Azure B1 Hub, Azure B1 Hub hyphen VNet. So this is created. Okay. So now the inside that, do we have this configuration or not? Let us see that. AZ B1 Hub VNet. Inside that, what are the subnets that we are having? We are having the jump server subnet 10.1.0.0, Azure Firewall, Bastion, Gateway, and Endpoint subnet. Okay, these are all the subnets that we are having. The requested 5 subnets are there. Now, where we are going to create the server? In the jump subnets. Okay, jump server subnet, we are going to create the server. Before that, let me create the network security group. And then I am going to create the server. Okay, network security group is created. Now it's time to create the server. So this is the image which I am taking, Ubuntu 24.04 LTS server latest. So that is the image which I am taking, and I am creating the server with the IP address 10.1.1.4. As we already discussed this is the jump server. Okay, jump, JUMP, jump server.
What's the difference between jump and bastion? Or you're going to cover that later?
I'm going to cover it. Okay, don't worry. Okay, this is the jump server. Now let it create. Now the next one is I am going to create a spoke architecture over here. So this is my AZ B1 AZ B1 hyphen SP1 hyphen hub. I mean SP1. I can give RG, but that's okay. SP1. Okay, this is the resource group which we are creating in the East US only. East US. Inside this resource group, what we are doing here is we are going to create a VNet. This is my AZ P1 hyphen SP1 hyphen VNet with the CIDR 172.16.0.0/16. This is the CIDR which we are creating. Okay. Now inside that, what we are creating? Inside that we are creating, if you want, you can create 2 subnets. Right now I am creating only a single subnet. We can create 2 subnets also. What is that? Here we have the subnet that is AZ P1 hyphen SP1 hyphen subnet 1 with the CIDR 172.16.1.0/24. This is the subnet. Inside that we can create a virtual mission. Inside this we are going to create a virtual mission. The virtual mission name is SP1 Linux server 1. This is the virtual mission name. I'll give like this. And then if you want, you can create one more subnet over here. This is the subnet which we are creating, AGB2 subnet. So here we are not going to create any sort of server. Okay, we'll see that. Later we will create the server. So right now this is my AZ B1 hyphen SP1 hyphen subnet 2. If you want the CIDR, that is 172.16.2.0/24. This is the CIDR subnet. Okay. And then we are going to create the another spoke. So this is the another spoke, and here it is AZ P2. So we'll create that, but before that, let me create AZ SP1. Okay, I want to create the AZ SP1. Later we'll come back and create the this configuration. What about this? The server got created. What is the proof? Let me go to the virtual missions. So here you can see we have a virtual mission created, which is a jump server. Okay, here you can see that there is a jump server which got created. Okay, good. So now what we are doing here is we are going for the creating this SP1. Okay, resource group is equal to AZB1 SP1, and we are going to create a server inside that SP1. Okay, automatically the server will be created with the IP address 172.16.1.10. So automatically in the sense, so through that command, it will be created. So the next spoke which we are going to provide here is this is my AZ B2-SP2, and this is created in West US. And then this is my AZ B2-SP2-VNet with the CIDR 172.17.0.0/16. And then this is my subnet. What is that? AZ B2 AZ B2 SP2 subnet 1 with the CIDR 172.17.1.0/24. Okay. Inside that also, I am going to create one more server over here. The server is SP2 Linux server. If you see here, what is the server name? Server name is SP2 Linux server 1 with the IP address 172.17.1.100. So this is the Linux server IP address. Okay, so this is the basic architecture which we are talking about. And here also you can create one more subnet, that is AZ B2 SP2 subnet 1 subnet 2 with the CIDR. What is the CIDR? 172.17.1 2.0. We did not create it, we will create it. Okay, so this is the architecture. And we need to create this spoke. Okay, let us wait for that. So here still the server is getting created. Now what I will do here is, so yeah, of course I will go with the Bastion host also. Before that, let me create the Bastion. Okay, so before that, what I want to do here is I want to create the Bastion. So here Bastion create Bastion. Okay, create Bastion in the hub I want to create it, and this is my Azure B1 Bastion. It is in East US. Availability zone none. So in any availability zone it can be created, and I will go with the premium tier, and the virtual network is AZ B1 Hub. Okay, AZ B1 Hub VNet. So this is the virtual network. So inside the virtual network, we already have the Azure Bastion subnet, that is 10.1.20.0/24. So this is the Azure Bastion subnet. Okay, public IP and the IP address name Azure -hub -vnet -IPv4. Or else if you want, you can give something like AZ V1 Bastion IPv4. Next. So I want an IP based connection, and I want the shared link. Okay, what is the shared link? We'll see that. So this is the requirement for the Bastion. Next, review and create. Okay, so create. It will take minimum some 20 to 25 minutes to create it, or else at least 10 to 15 minutes to create this. So that's why I created right away here. Okay. So now here the servers are created. SP1 is created, and then I will go with the SP2. Let me copy this. SP1 is there. Virtual machines, we need to have the SP1 Linux server, and then this is my VNet, SP1 VNet, which got created with the subnets as Azure SP1 subnet is there. Okay, with the IP address range as 172.16.1.0. Okay, good. Now, what is this hub? Whatever the communication that is happening, in general, what will happen here? Okay, so this is my internet. From the internet, if I want to communicate with my backend servers, whatever the servers that are there in the hub network, we will be able to communicate through the VNet. So in between these two, hub and spoke, we are going to create a VNet peering. Okay, here also we are going to create a VNet peering. So this is my hub to SP1 peer. Up to SP1 peer, as well as SP1 to, or else I will call it as SP1 to hub peer. SP1 to hub peer. Anything you can call, from right to left or left to right. Okay, that is fine. So here also what I will do, SP2 to hub peer. So bidirectional communication will be there. So like this, we are going to create the peering connection. Okay. So here what will happen, as we have the IP address to the public IP address there is for the servers. So the default outbound access will be there. They will be directly able to communicate with the internet. So as we have provided the default public IP, so if I am trying to connect from my computer, to my server, to my any one of the server, those servers will allow it. Why? Because the servers are having the public IP. As the servers are having the public IP, they will be, and they are created under the internet, which is having the internet access. So that's why what is going to happen, I will be able to connect to my servers, whatever the gem server, SP1 server and SP2 server, I will be able to connect. So to make you understand this, what I can do here is, let me log on to all the servers. Here the servers are created. I'll go back to the where is it? Yeah, compute infrastructure. hub Linux server. What is the IP address of the server? The IP address is this is the public IP. Okay, let me log on to the server. 1 second. Connection is for every 5 seconds. Save it and open. So login as Azure admin. Azure admin latest hash 12345. So this is the password. So we are logging into the hub server over here. So this is the hub server. Okay. And then we will be logging into the spoke server. That is spoke VM1. What is the spoke VM1 IP address? So this is the spoke VM1 IP address. Let me copy it. Open. Accept it. And this is also Azure admin and the password is latest hash 12345. It will be logging in. Okay. And then this is my spoke 2. So this is the spoke 2 server. New session, Azure. I'll give like this. Azure admin latest hash 12345. Done. So these are all the servers which we are having. So this is the hub. These two are the SP1 and SP2. Okay. So here you can see like this. I am going to take tmux terminal multiplexer. Oh, sorry. Sudo su hyphen. It has already divided. No. Okay, no problem. Control B, shift double quotes. If you press like this, there will be two terminals that are available. So from my hub server, I want to ping 172.16.1.10. There is no communication. Control B down arrow. Ping 172.17.1.10. There is no communication. In the Linux server 1, in the SP server, SP2, SP server 2, no. So I want to communicate with 172. I want to communicate with 10.1.1.4 with my jump server. And here also SP1 server, ping 10.1.1.4. So between all the servers, the communication is not established. Why? Because there is no peering connection. Okay. So now what I can do here is I can go ahead for the peering connection between the servers. So how I can establish the peering connections? Let's see. This is the client. We are able to access those servers. We are able to access the spoke servers. Now what I will do, I will go back to my virtual machine network. Yeah. So this is my virtual network. So from hub to, let me go to the peerings, add peering. What is my remote network? My remote network is SP1 to hub. SP1 to hub, dev subscription, and virtual network is SP1. Remote virtual network is SP1. So from where we are creating the peering, that is important. We are adding the peering on the Hub VNet, so that what will be the virtual network? SP1 will be the virtual network. And what is the local peering? The local peering is hub to SP1. Okay. Allow AZB1 Hub VNet to forward the traffic to AZB1 SP2 VNet. And when I click on add here, then that configuration, that peering will be established. Which peering? This peering. So once the peering is established, here you can see the communication will start. From SP1 to hub and hub to SP1, the communication will be starting. There you go. So from SP1 to hub and hub to SP1, the communication got started. Okay. Now another peering connection we have to do. What is the another peering connection? Add. This is my SP2 to hub. SP2 to hub. And then remote virtual machine is SP2 and the local network is hub to SP2, hub to SP2. Just give me a second and add it. So both the connections are established.
Chaitanya, question.
Yeah, tell me.
So this peering can be done from only from subnet to subnet, not to VM, right? Is it
We
always like
created from
subnet level?
VNet to VNet. We created from VNet to VNet,
Oh, we
not from subnet. We created from VNet to VNet.
VNet. Okay. So it's
Hmm.
always from VNet to VNet.
Yeah, that's what
Appearance.
the communication between two VNets, between the resources in two VNets, we don't have the communication. No? There will be isolation between the VNets. So VNet to VNet communication we are establishing. Okay. So here you can see that what is there, subnet to subnet is also there. But we are creating the VNet net, virtual network to virtual network peering. Okay.
Then why in the below we are picking a particular subnet, right? Like if you go back to the configuration.
Hmm. Here I am selecting only the VNet, no, not the subnet.
Correct, but below that the checkboxes are VNets, right? Or
Yeah,
no.
VNet only there. The
Oh,
checkbox is
VNet
also
only. Okay,
VNet
it's
only.
okay. Okay, I read it. My mistake. I thought it was subnet.
Hmm.
Okay, thanks.
Yeah. So the connection is successful up to SP1 and up to SP2. The peering connection is there. See, previously we used to have default outbound access. There is a term called as default outbound access is there in Azure. What is the default outbound access in the sense? This is deprecated now from May 31 to May 30, 2025, I think. But what is this default outbound access? Azure. See, whenever we are communicating, we have this Linux servers are there, no? So these Linux servers will be able to communicate with the internet if they don't have the public IP also. Okay. So default outbound access in Azure. What is that? In Azure, when you deploy a virtual machine in virtual network without an explicit defined outbound connectivity method, Azure automatically assigns an outbound public IP address. What is the meaning of this means? For example, here you can see the servers are there. All the servers are having the public IP address. If you don't provide the public IP address for the servers means, if you don't provide the public IP address for the servers means, then Azure will automatically assign an outbound public IP address. It will assign the outbound public IP address. And this IP address enables the outbound connectivity from the resources to the internet and the other public endpoints within the Microsoft. So this particular IP address will enable the outbound connectivity. So without the public IP, we will not be able to communicate with the internet. So definitely we need to have the public IP. So that public IP will be provided by my Azure. So for example, if I go with ns lookup if config.io, so there will be a public IP that will be assigned. Okay, so to check out, we are having a command called as, one second. NS lookup command is helpful for use if config or ipconfig. I just forgot that. One second. I think if config only. So it is going to show you the IP address, okay, for you. But the point is, if you don't have the right now, we have provided the public IP to the servers. If you don't provide the public IP to the servers, then what will happen here is Azure will automatically provides the public IP address, and that process is called as default outbound access in Azure. So, but now what happened here is how and when default outbound access happen if virtual machine is deployed without explicit outbound connectivity method, which means that without any public IP, Azure assigns as a default public IP address. This IP known as default outbound access IP is owned by Microsoft. So this IP address is given by Microsoft to my server and can change without notice. Additionally, the default outbound connectivity relies on the implicit platform behavior and may be affected by the platform level changes. So now, what about this NAT gateway and instance level public IP? We'll see. So first of all, next to hop traffic is directed to the virtual appliances, and the NAT gateway is attached or not. If NAT gateway is not attached, so NAT gateway in the sense network address translation, especially it is used in the private subnets. We'll see this in the next session. Public IP is associated to the IP configuration, which means that that server is having the public IP or not. If that server doesn't have the public IP, then what will happen? Our Azure is going to provide a default outbound access, like Azure is going to provide a default IP address. But what is happened here is for API released after March 31st, 2026, new virtual networks default to use the private subnets, meaning that an explicit outbound method must be enabled in order to reach the public endpoints on internet with Microsoft within Microsoft. So what they are saying, if you want to communicate with the internet, then definitely you should have the public IP address towards your server. Without the public IP address, you will not be able to communicate. So what is the proof? Let me show you. So what I can do here is I will close these two servers as we already have the access for those two servers. SSH Azure admin @ 172.16.1.10. I am logging into the first server. Okay, that is SP1 Linux server. I mean this particular server, Spoke 1 Linux server. I am logging in as it is having the peering connection. Hub and Spoke will communicate with each other, and I will provide the password latest #12345. Okay, good. We are in the Linux VM. Ping google.com. We are getting the response from the google.com. Okay, good. So now I will come down here also. What I will do, SSH Azure admin @ 172.17.1.10. Yes, and the password is latest #12345. Done. So here also what you can do, you can check for ping google.com. So we are able to communicate with Google. Okay. Now what I will do here is I will go back to my IP address. IP address KDD IP addresses. Public IP addresses are there now. So I will go to the public IP address. So the public IP addresses which are connected to my servers, I am going to remove them. So here, why we are having, for the Bastion there is a public IP. Okay, no problem. For SP1, whatever the public IP address is there, I am going to dissociate it, and I'm going to remove that public IP. Previously, what used to be happened here is when the default outbound access is there. Right now, we don't have it. That is deprecated. But previously, what we used to have here is when we delete the public IP for a server, okay, then automatically what happened here is for that server, Azure used to provide an public IP address. But right now, what is going to happen if I go back to the server 1, and if I try to ping google.com, previously we used to have the communication, but now we don't have the communication with the internet, as I have removed the public IP. So when it is trying to communicate with the internet, it is not communicating. Why? Because Azure is not providing any default outbound access IP addresses to my server. So that's why it is unable to communicate with the internet. Okay, so the same manner, what I am going to do for SP Linux server 2 also, I am going to remove the IP address. When I remove the IP address for the Linux 2 server also, then what will happen? We will be not able to communicate with the internet from the spoke to Linux server, ping google.com. Look at that, we are unable to communicate with the spoke to. And not only that, we will be not able to log in. So if you want to log into that service, definitely you need to have the public IP. Without public IP, how you will be logging into the server? You see, so if I want to log in into the server, definitely I need to have the public IP. Without public IP, I cannot log in. So that's why what I am doing here is I am first logging into the jump server. From the jump server, I am logging into the SP1 server. And from the jump server, I am logging into the SP2 server. So if I want, I can make completely this subnets as the private subnets. How I can make these subnets as the private subnets? If you go to the VNet, SP1 VNet is there now. So under that we are having the subnets. What are the subnets? AZB1 SP1 subnet is there now. Enable private subnet, no default outbound access. I can enable it. When I enable it as a private subnet, then what will happen? Private subnet and public subnet. The subnets which are exposed to the internet, those are called as private subnets. Sorry, public subnets. The subnets which are exposed to the internet are called as public subnets, and the subnets that are not exposed to the internet and local communication is there within the VNet communication is there, then that is called as a private subnet. So we just made a subnet as a private subnet. Here SP2 also, SP2 VNet, I mean in the SP2 VNet, whatever the subnets that we are having. So I will convert the subnet as a private subnet here. Now both the subnets are converted as a private subnets, and these servers doesn't have the connectivity with the internet. Okay. So now what we can do, so to access this servers, first of all, I am logging into the jump server. From the jump server, I am logging into the Linux server. And here also from the jump server, I am logging into the second Linux server. This is how I am logging in. But we have created the Bastion server. So here you can see, where is this? We have created the Bastion host. As we have created the Bastion host, it is nothing but it's a previously in Windows there is a feature. Now also we have that WebRDP. Okay, WebRDP is used to be there. Okay, what is this WebRDP? Get started with web client for remote desktop. So remote desktop web client lets you to use the compatible web browser to access your organization's remote resources published to you by your admin. You will be able to interact with the remote apps and desktop like you would be with the local PCs no matter where you are without having to switch to the different desktop PC. So uh, directly from the browser, you will be able to access your servers. Okay. So that is what WebRDP means. So this is what the Bastion host will be doing. So now, as you have asked me something like Bastion versus Jump host. A Bastion host and Jump servers are often used interchangeably to describe the hardened server acting as a secure gateway to the private network. Bastion host focuses on the security hardening at the top parameter, where Jump server emphasizes the functionality of hop to access the internal system, bringing the security zones. Both are looking alike only. Both are the same, but only the functionality is going to be different. Okay. So from the jump server, what we can do, we can log in into the jump server. From there, we are able to access the rest of the server. From the Bastion also, the same thing will happen. Both are intermediate machines that minimize the attack surface by centrally remote access, and to isolate the private networks, reduce the need for direct access to the individual servers. Okay, so we won't provide the direct access to the individual servers which are located. So I don't provide these individual access to the external users. So definitely any user has to log in into the jump server or Bastion host to access my private servers. Okay, typically deployed in the DMZ within the public subnet to accept the incoming connections. Security focus. They are often combined a hardened Bastion host functions as a jump server for operational functionality. It is not very much more difference is not there. Parameter security hardening and security network level transfer. Both are in the DMZ level only. Okay, but this is in the public subnet and it is in the edge networking. Extremely high. Hardening means security level is high, and operation door and the pathway. It's like a bridge and it's like a entry point. So both are same, but only the difference is the way of accessing is the difference. Okay. So if I go back to the Bastion host over here, I want to connect. So previously what I used to do, I have a jump server. I need to log in into the jump server. From the jump server, I have to connect to my backend services. Whatever the VMs are there, to my backend VMs, I need to connect through SSH. But right now here for the Bastion, we are not going to use like that. Something different we are going to do, connect. The IP address of the server is 172.16.1.10 through SSH, and the username is admin Azure, Azure admin, and the password. When I click on connect, there you go. We are able to connect to our server through the browser like this. So if you want to access anything, you can access directly from the browser itself. You don't need to access it somewhere. So if I want to provide the access, okay, if I want to provide the access, I can simply provide the link over here. There will be shareable links will be there. There will be shareable links. Add resource group is not this one, SP1 and this server. Apply. So when I apply this, then I will be having the Bastion shareable link will be available for me. Okay. So simply what I can do, I can simply provide this link to the user. So if you want to access that server, simply go to this particular link. When I provide this, the user will be able to directly access my authentication is password and the username is Azure admin, and the password is latest. I will share the password through the email, and I will ask the user to log in into the server, so that I don't want to share the IP address to the user. IP address, and as well as I don't want to share any network related things. So simply what I can do, if you want to access the server, access this URL. From there in the browser, you can access the server directly. So this is the shareable links. Okay. So this is the concept of your Bastion host. Okay, with the help of Bastion host, what we can do, we can create the shareable links so that we don't need to provide the IP addresses to the end customers or asking them to connect to the jump servers, from the jump servers asking them to connect to the backend server. Simply what I can do, I can create a shareable link and I will ask the users to access that link and in the browser, and so that they will be able to access my server. If I want to access it, simply what I can do, I can go to the connect option, and in the connect option, what I can do, I can provide the IP address of the server, and then I will provide the username Azure admin and the password. If I provide this directly from the browser itself, I am able to access my servers. Okay. So this is the Bastion server, which is created inside the inside the Bastion subnet here. Okay, this is my Bastion host.
But Bastion is additional cost, right?
Yeah, obviously. There will be additional cost. Of course, the gem servers also will have the additional cost.
Yeah, that'll be a VM cost directly.
That will be the VM cost. Okay. So if you, I mean, from the Bastion host, we have multiple use cases are there. So which is shareable link, which is more secure. You don't need to share the gem server IP address. You don't need to share the credential. Of course, credentials,
Correct.
the server credentials you have to share, but any which ways, you don't need to share all the IPs. So simply you can share the link and ask them to log in into the server through the browser. So that will be one of the benefit. And the second one is, so if you want to access the servers, you don't need to log in into the gem server again. So from the directly you can go to the Bastion host, and if you click on connect, it will be connecting to that servers. Okay. So this is one of the advantage. Like we don't need to access the putty or else any additional tools. So simply we will be able to access those servers through the Bastion host. Okay. So this is the benefit of your Bastion host, and as well as we have removed the public access to my servers. Okay, so tomorrow what we will do here is we are going to create the NAT gateway, and we will allow the, see right now the servers are not able to communicate with the internet. Okay, they are not able to communicate with the internet. What is the main use case of NAT gateway in the sense? For example, let me take your home example. In your home or in my home, for example, I have multiple computers are there, like there is a laptop, smart television is there, smart TV, there is a desktop, there are multiple laptops are there. Okay, multiple laptops are there, and there are multiple mobile phones are there. If all these devices needs to get the internet, okay, if all these devices needs to get the internet, every device should have the public IP. So if any device that should get the internet means they need to have the public IP. Without public IP, we are unable to access the internet. But here what we are having, we are not having for every device, we are not going to get the separate public IP addresses to access the internet. So every device will have only one common IP address, that is the private IP. Then if we are having the private IP, I mean, if the devices are having the private IP, then how they will be able to communicate with the internet? Private IPs are actually used for local communication. From device to device communication, we will be using the private IPs. Within the local communication, we will be using the private IPs. But if I want to communicate with the internet, definitely I need to have the public IP. So for that, what we are going to do here is we will be communicating with the internet service provider to provide the internet for us. So yes, the internet service provider will come to our home. We'll check out for an what I can say, a box. Okay, internet box is available or not. From that internet box, he is going to collect a cable and connect it to connect it to our router and in the WAN port. Okay, they will connect this to the router's WAN port. There will be inside the router, you can check out, there will be a WAN port and LAN ports are available. Among the WAN port, they are going to connect this public cable. And then in the back end, what is going to happen here is they will be providing the public IP addresses, public IP to my router. Okay. So there will be some public IP to my router will be there. So that is what I can say. Public IP will be there for my router. And the IP address will be like 49.x.x.x. So any IP address, any IP address in the range of public IP, it will be there, so that the internet access will be there. Okay. So here you will have the internet access. Now within the home devices, how they are going to communicate? For every home device, you will have a private IP. Private IP address will be there. Okay. So in the computer also you will have the private IP. Laptops also you will have the private IP. In every device you will have a private IP. Okay. Now, how they will be able to communicate with the internet means inside the router, there is a special configuration called as NAT, Network Address Translation, which will be translating the private IPs, whatever the private IPs are there for my server, for my computers or for my devices. They will be, when they are requesting, the request will be noticed by the router. So the router will map the private IP to my public IP. Okay. So, and then the request will be going on to the internet. The request will be going on to the internet, and whatever the request that is given by the servers, or else whatever the request that is done by my computers, so those requests will be sent to the internet. From there, the data will be collected. For example, this computer requests some data. So the private IP address of this server is, for example, this computer is 192.168.1.100. So this is the private IP address of this particular server. So the request will be going with the IP address only. Up to the router, it will be going with 192 series only. But from the router, what is going to happen? This router internally, we have the NAT functionality is enabled, network address translation, which will convert the private IPs into the, which will map the private IP to my public IP. And from the public IP, it will be reaching out to the internet and collecting whatever the data that it wants and go back to my router. So from again, from the router, the public, vice versa, the public will be translated to the concerned private IP address and it will be sent back to the concerned server or concerned device. So this is the concept of NATing, network address translation, which we are going to discuss in the next session. Okay. Do you understand what is NAT means?
Yes.
Okay. So tomorrow what we will do? Yeah.
Chaitanya, on the NAT, right? If we host a web server, right, or website, and then we go through NAT for external people to talk to that
No,
particular
external
website.
people cannot directly talk to the website. If
Or
you
through
host
NAT.
a,
Oh, it's only outgoing, not incoming?
yeah, it is only for outgoing. See, you have a computer in your home. Any outbound traffic is directly hitting onto your computer until you request the data. Directly any data is getting downloaded into your computer, or else directly any person is able to connect to your computer.
No, no.
If you
Yeah, we
request,
access the internet.
then only the response, in the response, the computer, the response will be there. Okay. Direct inbound access, directly a user from the outside, if he wants to, if that user wants to access the data, or else if they want to access the server, they will not be able to access if the servers are in the private subnet and the NAT is enabled. So NAT is like a security guard. So for example, if you are entering into the office, what is the work of security guard? He will check the ID card, whether this particular employee belongs to my office or not. So once you enter into the office, and then whenever you are leaving the office also, you want to have some tea break, or else you just need to have a lunch break. So you just coming out of the office, the security guard won't stop you. So he will allow you to go to the cafeteria and have your lunch or else tea, or else if you want to go outside also, he will allow you to go. Why? Because you are the employee of that particular organization. Whenever you are returning back, what he is going to do, he will check the ID, whether this particular employee belongs to my company or not. If you are wearing the ID card, then the security guard will allow you to enter into the organization. If anybody from the outside is trying to enter into the organization, then what security guard is going to do? Is going to allow him. If he have the proper permissions,
No.
then he will allow. Otherwise, he is not going to allow that external person to enter into the organization, right? In the same manner, NAT gateway will also do the same. If any request that goes from internal to the external, internal means from my private network to the outside public network, and if the data is coming back as a response from the outside to the inside, it will allow. Okay. But if any request that is directly coming from the outside, the NAT will not allow that request to enter into the private server. Okay.
Okay.
Clear? No? Confused?
No, understand. Thanks.
Okay. Good. So that's the concept of your natting, which we will be discussing in the next session. So I'll save this diagram. This is my Hub-Spoke. Save it. And then I will delete only the Bastion host and the servers. If there is a requirement, tomorrow I will create the Bastion host again before you are joining to the session. After, or else after you are joining to the session also, I will create that. So now I can simply delete the servers. I won't delete the VNets and the resource groups. Okay. If I go back to the Bastion properties, where it is, delete the Bastion host. Done. And as well as I will delete the VNet peering also. Tomorrow we can create, if that is required, we will create again tomorrow peerings. I will delete both of them. Okay, good. So the network will be as it is. We will have the disconnected. Why it is not deleting? Okay. So I will delete these things again tomorrow. If I want, I will create it. Tomorrow we'll discuss about the NAT gateway, and then we will see the Active Directory configuration. Okay, deploying a Windows server, and we will try to create the Active Directory, and then we will be going ahead into the next concepts. Okay. Have a nice day, and we'll meet in the next session, guys. Bye.